So we're going to end this week by talking about afferent feedback from exercising muscle. Okay, and so this ties into the last lecture. It would just seem like it was good to have a break where we're talking about how the cardiovascular, respiratory, and muscular systems all work together to maintain homeostasis. Okay, and so we're going to talk about how this all affects breathing. Okay, now you have to remember that when you get ready to exercise, your ventilation is actually increased. Okay, it's not enough that you're like hyperventilating or like noticeably hyperventilating, but you're breathing more than you need in that moment. And the reason why is due to something called central command. This is a positive feedback loop. What's happening is the motor areas in your brain are letting the cardiovascular centers know, hey, it's almost go time. So if you could help get things going, so when we need more oxygen, that oxygen is there, that would be great. Okay, this is the reason why your heart rate increases, your ventilation increases, all of those things increase before you exercise. So we've got a picture here of all these swimmers on the blocks. I guarantee you all of their ventilation and cardiovascular measures are increased because their body is preparing to exercise. Okay, it's not necessarily anxiety. There is obviously a component that could be with that, but this is going to happen anyway because your brain knows you're getting ready to exercise. Now with muscles send afferent signals to the brain, letting them know what's going on. What's really interesting is shown by this figure here, and this is right out of your textbook. Okay, so on the x-axis, we've got time. On the y-axis, we've got speed and ventilation, and we've also got on the right x-axis or right y-axis, we've also got the load or the force that they're pedaling against and the CO2 production. Okay, so what I want you to do here is focus on RPM. Okay, what happens to ventilation as RPM increases? Okay, notice that load is remaining relatively constant. Okay, but if you notice, ventilation, so that's this blue line here, increases almost at the same time. It's a little bit offset as movement increases. So more movement leads to more breathing. Okay, so when your load stays constant, but you increase the frequency of movement, that seems to increase your ventilation. Okay, now we've got another one here. So same figure, but on the right side, what they've noticed is that if what you do is you maintain speed, but you change your workload, so maintain speed meaning RPM. So what's happening here is that these guys were maintaining an RPM of about 75 revolutions per minute, but during this exercise, because they've got some cool fancy equipment, they can increase or decrease the load. Notice that as the load increased, ventilation was really offset. It took a little while before ventilation increase to kind of match the change. And so what this suggests is it's movement. Just the act of moving will cause you to breathe more. Okay, even if you're doing the same work, moving more causes you to breathe more. Now, the last thing I want to share with you is a study done by somebody I've actually worked with. He's actually a colleague, friend of my advisor from the University of Oregon. Dr. Aman, he's German. He's from Germany, but he works at the University of Utah. Both he and my advisor did some work before they're at their current positions at the University of Wisconsin-Madison in one of the leading respiratory labs in the world. And one of the things that Dr. Aman wanted to understand was the relationship between afferent feedback from the muscles and breathing. And so in 2010, he did this study, or at least the study was published in 2010. And so he had subjects complete two bouts, one where they were given a placebo and one where they were given an injection of fentanyl. Okay, and the reason they were given fentanyl is fentanyl blocks afferent feedback from the muscles. Okay, and so during the same, everything else was the same. It was just, did you get a shot of a placebo or did you get a shot of fentanyl? And what they found was during the trials where these subjects received fentanyl, they had lower ventilation, they had higher CO2, lower oxygen, and lower heart rate. Okay, and what does this tell us? Well, this tells us that not only is it important what's going on in your bloodstream, we've got chemoreceptors that measure and that monitor this stuff, and by stuff I mean CO2 and oxygen. But the feedback that we get from our exercising muscle is important as well. If we get rid of that feedback, what was happening was these guys were essentially hypoventilating. They weren't breathing enough for the type of work or type of exercise they were doing. So muscle feedback is really important to help maintain homeostasis. If we get rid of that muscle feedback, it's very difficult for us to stay in that or get back into homeostasis after exercise starts.